Hi guys, Nick here with BitGalaxis, bringing you a new video on Unity3D programming and scriptable objects, what they can do and how to use them. And to start out, we're going to talk about some code concepts, and then we're going to jump into a very simple demonstration of how to implement scriptable objects. So before we get into anything, we need to unlearn something. When you start out in Unity and you create a script, you're going to get this template, and this template only has one unique thing about it every time, and that is the class name is unique and it matches whatever the script name is, right? So if you create a new script called new script, it's going to create this public class new script as well. And everything else is just dumped in here by Unity by default. So what is all this other stuff that we have? Well, you have this using systems collections, using Unity engine. This piece is just saying, hey, there's some code that either Microsoft made or Unity made that we want to reference. We're going to use that code. Well, why do we need that? What code are we using that they made? Well, actually, it's this MonoBehavior. Now, hold on. This is the part we're going to have to unlearn. This is the part where we really need to focus. MonoBehavior is a class that we are inheriting from. My script with this little operator is saying, hey, my script is going to be a MonoBehavior. What I mean by that is I get all the properties, all the methods. So we have the start function and an update function. These are part of MonoBehaviors. They're built in, right? When you make a class, which is the core building block of code when you're using object-oriented programming, classes are not unique to Unity. They are part of C#. They're part of Java. Lots of different programming paradigms use classes. So this is not unique to Unity, but we have start and update. We could make our own, but MonoBehavior gives those to us, so why recreate them? So this is the piece we're taking away when we go to scriptable objects. We don't need them for that. So wait a minute. Well, how do we break away from MonoBehaviors? What are MonoBehaviors? Well, let's talk about what they're not first. MonoBehaviors are not required in a script. Yeah, we use them all the time, but they're not required. And scripts are not dependent on them. You don't have to make a Unity program or Unity class be a MonoBehavior. You don't have to do that. That's just common, right? So MonoBehaviors are required for scripts that are components on a game object. That's why we need them so often. We're using MonoBehaviors because most of our stuff is game objects, right? We have something in the game. We need to interact with it. It needs to be a MonoBehavior. Well, wait a minute. So what's the point of scriptable objects then? Okay, well, scriptable objects, they're data, right? They're uncoupled. That means they don't have to be tied to an object. Okay, you could probably think of several reasons why this might be beneficial. Like it's not tied to an object, but objects can access them. They can go into those scriptable objects and see what that scriptable object contains. And they are also structured data. So that means that there is structure to that data. I want to, use a scriptable object. I need to know how to access that correctly. It's not just data out there anywhere. There is some structure to it. You can make it like an object, but only as a reference value, not something in your game. Okay, so let's talk about something real quick. Before we really start getting into benefits and all that stuff, let's just really quick go over how we implement them and then demonstrate it, and then we'll kind of come back around to that. So the first thing is when you want to create a scriptable object, you have to create a script just like you do for a game object. But in that script, you got to create a way to create the scriptable object. You've got a script, but you also have the scriptable object. And then you have to make your other game objects reference those scriptable objects. Okay, look over here on the left. I've got all these little steps exactly. If you want to know how to do this, then you can look at these steps in detail. I'm not going to cover that because we're going to demonstrate it. But just know the key points. Make a script. That script needs to give you a way to create the object itself, the scriptable object, and then your actual game objects are going to reference that scriptable object, and that's our implementation. So let's go ahead and jump into the fun stuff. Okay, so I'm in Unity and I've already pressed play, and I've got this scene set up from a previous video and I've added some elements to it, but basically I've got this buggy, and this buggy, if I press my key and I start moving forward, it's got a power level. I think the power level is set to 100 right now, and you can see it goes real slow, right? I could turn it, but it's going super, super slow. And if we look at our buggy here, I call it boring buggy. I have given it a power level of 100, and that's the focus of my demonstration. We're going to put power into a scriptable object and be able to modify that and reference it from our buggy. So let's take a look at our power scriptable object. I've already created this, but let's look at the script, okay? So, okay, you see here, we have this using again. We're just using code from somewhere else. No big deal, right? Okay, but we now have this create asset menu, file name data. I don't know what that means. Okay, we'll look at that in a second. Menu name, my objects / power. Okay, we'll visit that in just a second. But we have this class, power, right? But remember in the first script, we were using MonoBehavior, and now we've changed it to Scriptable Object. Okay, well, there's our object. We've got our Scriptable Object. Okay, what does this mean? Now I have this public float power value. Okay, let's just jump into Unity and see how this works. Okay, I'm going to show you this create asset menu. We're going to demonstrate that. We're going to show you how we make the Scriptable Object. Okay, so if I right click in my editor, I now, we go to our create menu, right? Oh, wait a minute. My object's power. Hold on a second. My object's power. That's the menu name that we just created, right? Okay, so if I go back here again, create my objects, power. Now I've created a power object. There it is. That's our scriptable object right there. Oh, and look, its name is data, just like I had specified in that create asset menu. So with that data, I'm going to go ahead and specify, okay, I want to make this a, I don't know, scriptable object. It's going to be our power SO, but we're going to say it's, I don't know, we're going to call it like a level, right? We're going to say weak power, right? And oh, look, our power value, like we defined earlier in that script, we had given a float value. So I'm going to say this is 100, just like the current power value. Okay, but my buggy is weak right now. It doesn't move very fast. I want to make a different power level. I want to create another power object, and I want to call it power SO strong, or I don't know. And so now I have this power value, this scriptable object, and it has a power value in it. And I don't know, let's make this, I don't know, 1500. We're going to multiply it by 15, right? So we have a low power value for weak and a high power value for strong. These are two different objects. Okay, so now I have my buggy, right? It's referencing this power value of 100 right now, but I want to change that. I want it to use my scriptable object. So, okay, how do we do that? Remember, we have this power. It's a class called power, and it's a scriptable object. So let's go back to our buggy. I could refactor all my code to simply reference that power scriptable object everywhere. And I'm going to change it to very simply incorporate the scriptable object. Okay, so how are we going to do this? Well, we have a public power object because we called it power. It's a scriptable object. And we're going to say power SO. We're just finding that, yes, that's our scriptable object. Okay, let's be very clear here. Power SO is a scriptable object. It is not its value because we gave it a float, but it could have a float. It could have two floats. It could have a float and a bool. It could have lots of things, right? So that we're just saying, hey, there's an object out there. Let's grab that. Okay, well, now this public float power, we don't need this. I can make this private. I'm going to go ahead and keep it, right? It's just our power variable, but we do want that power to get its value from the power scriptable object. So what I'm going to do is in start, I'm going to say power equals power SO. Oh, wait, remember how I said it's not actually the value, it's the scriptable object itself? If we put a dot operator, just like any class, we can now actually, grab the power value. And I'm like, remember, we set that float value, so it could either be 100 or it could be 1500. And now if we go ahead and save this script and go back to our game and click on our buggy, now we have a power SO. And if we drop in our weak power, which I don't know if I maybe named it too long. So let's do this. There we go. Weak. So it's a weak power, right? And let's play. Okay. So we chose weak, which is identical to the 100 before, right? Well, Nick, have you actually changed your code? Let's question that. Let's go see if we actually did. If we change this power strong and drop it in here, now we should see that our buggy goes a whole lot faster. You can tell we really are speeding along. And my buggy is buggy. I have some camera issues. I have some other issues going on right now. It's not slowing down at all. But anyway, but you can see it went a whole lot faster. So clearly we've changed it. Just by doing that, those simple steps, we have created our Power script. We have created the objects and we've given them values. And then we've also gone to our buggy and then we referenced that scriptable object with its value as well. So changing our script to do that, we now have these objects that just store one value. And we can change that value, we can swap it out, we can make multiple objects of different values. We don't even have to use these as power. We could just say, you know, we could specify speed if we wanted to really, which, you know, it's related to power, but you could just make it a speed. You could make it, I don't know, a quantity for anything really. So I wanted to revisit how we did that scriptable object script because I jumped over it to demonstrate how we do it and its meaning, but I wanted to go back over it after knowing that because we have this class, the script we called power, this class, we are inheriting from scriptable object. That's a key part. And then we have this create asset menu. Remember we had a file name. When you create that object, it's initially going to be called data. I renamed that to power SO weak, power SO strong, but then I also have that menu name. So when I right click in the editor, I have a my objects menu option. When I click create, there's my objects, and under my objects there's also power. So you could have different scriptable objects and you would give them different names, and that's how you create them. Okay, so let's do a real quick comparison. All right, so MonoBehavior linked to game objects. The data and functions are accessible through those game objects, so you can't access them outside the game object, and they're dependent on the availability of associated game objects in a scene. So you have to have an object in the scene. A scriptable object, they're not linked to game objects, and they can't be. They're not a component of a game object, but they are available in the editor. And data and functions are accessible from those objects, but not dependent on them. So you don't have to have a game object. You can have a scriptable object. And they're also, because they're not part of a scene or a game object, they're accessible between scenes. So you can store a value. Let's say that you have, let's talk about the benefits now that we've kind of implemented one. Let's think about the possibilities here. A scriptable object's values can be changed, and objects referencing the scriptable object will update automatically. Now, in the case of the script we created, they will not, because they only did it at start, but you could put that same information in update, and you would set the power level equal to the scriptable object's power level, but you can always update them on the fly. Now, this only applies to the objects, not the scriptable object script. If you change that script, then you're also going to change the values potentially. You don't necessarily have to, but if you're removing something, you're going to lose those values. So let's say in development, you want a way to change the difficulty for testing. One method, you can implement a damage multiplier scriptable object, and you can reference that multiplier from every enemy. Once you have it in place, you just simply modify the damage multiplier value on that scriptable object, and all enemies can change, even in play mode. So think about the benefit here. Okay, you have, let's say you have prefabs, right? Why wouldn't I just use prefabs? Well, let's say that you want the difficulty level on every type of enemy to change, right? What would you have to do? Well, without a scriptable object, you would have to change every single prefab. But if you have a scriptable object and you've built that multiplier onto every single prefab, guess what? That scriptable object now controls every enemy, one change, without having to modify any code or open a prefab. You just find that one global value and modify it. Very powerful in certain scenarios. The data contained in a scriptable object can be referenced from multiple objects in multiple scenes. You cannot put a scriptable object on any game object. They cannot have a transform. Why is that important? They cannot exist in the scene or the scene hierarchy. Both of those are accessed or part of transform. Can't put it in the game. It's just sitting there. It's just data, like a little note. And then multiple objects of the same type can be used to create a variety of values. For example, weapons. Let's say that you have weapons. Every gun just has a different model, but it outputs something different, right? So it looks different, but you could say, all right, I made a pistol, but it can shoot rockets, right? Well, then you could do that on the fly, and then you realize, oh, I made a mistake. I've got to change the bullet output to something else. Just modify it real quick. So you can see the benefits of scriptable objects. There are many, and there are many ways to implement, and you can, again, we did something very simple. We took one value and we modified it and we changed it. And so That's all I had for you guys today. I want to thank you for watching, and I hope to see you next time.